In the following exercises, solve each system of equations using Cramer's rule. Now, in previous videos, we've used different methods to solve these, but this one wants us to use Cramer's rule. So if you look below here, we have x equals dx over d, and y equals dy over d. Now, down below, dy, dx, and d are defined. So d is actually a1, b1, a2, b2, and that's just what they call the coefficients matrix. That's just using the coefficients of x and y and creating a determinant with those. And that's going to be d. And then the next one is I take this d here, I remove the first column here, and I put the constants there of what my equations equal in that first column there. And then for dy, I take that d here, and I put the a1, a2 there, and then I put in place of the second column the constants that it equals. So what we're going to do is we're just going to run through this process now. So the first thing what we're going to do is we're going to look at this 3x plus 8y, 2x plus 5y, and we're going to find d here. So my d is going to equal 3, 8, 2, 5. And there it is. And again, it's just the coefficients for my x's and y's, and that's my determinant I'm going to find here. And that's just going to be 3 times 5, which is 15, minus 8 times 2, which is 16. So that's going to equal negative 1. Now for my dx, that's going to be, I'm going to take that same d here, and I'm going to remove one of the columns. And if you look at down below here, this is my dx. So my second column stays the same, so that's just going to be my 8, 5. And my first column is now going to become the column of constants there. So that's going to be negative 3, negative 3. And that determinant is going to be negative 15 because it's the negative 3 times 5 minus, and that's going to be negative 24. So then our final answer for this one is going to be, that's really plus 24. So that's going to be a positive 9. So then my dy here. So if I look at my dy, that's down here. So for the d, my first column stays the same. Okay, so that's going to be 3, 2. And it's just coming from up here. And then my second column is going to become those constants now. And that's going to be that negative 3 there. I put it in there, and there we go. Now I do this determinant. And that's going to be negative 9 minus, and that's going to be negative 6. So then my answer for dy then becomes negative 9 plus 6. So it's actually going to be a negative 3. So now we have all the information we need to complete our problem. Now in the beginning here, it says x and y equal these dx over d and dy over d respectively. So what that means for us then is x is going to equal my dx, which is 9 here. So it's going to be 9 over d here. D here is the bottom, excuse me. So that d is going to be negative 1. So negative 1. So it's actually negative 9. And my y is going to be my dy. So my dy here is negative 3. So that's going to be on top. That's what we see here. And that's going to be over d as well. We know d is negative 1. So we get a positive 3. So if we had to write this as an ordered pair, it would be negative 9, 3. So that would be our answer for this first one. Now for the second one here, notice here I actually have a 3 by 4 matrix I would create here. And this is only set up to solve for x and y. We actually have a z as well. So this Cramer's rule will not work for us here. We'll need the modified version of this. So here is that version. So now we have a dx, dy, and dz we have to find x, y, z. And the process is still the same. It's just going to take us a little longer to get there. So for d then, d is just going to be the coefficient matrix. That's what we call it sometimes. And it's the determinant of that. Excuse me, let me be clear. Okay, so this is going to be 6, -5, and 2. And then 2, 1, -4. And then 3, -3, and 1. Now again, I'm just taking all the coefficients of x, y's, and z's for each of those equations. Now to do this determinant, and we're just going to run through the first one here. I'm not going to do this for each of these because we're going to actually have to do 4 determinants here. And I'm not going to do all of those. I'm just going to do one, and then I'm going to show you the answers for dx, dy, and dz. But I will show the setup of those. So looking at this first one, it's going to be 6. And again, I cross off the row and column of that, and I'm going to end up with 1, -4, -3, and 1. Now again, when I cross those off, look at what I have here, and that should match. Okay. Oops. So then the next one's going to be a negative. I always negate it. And that's going to be a -5 there. So I'm going to put the -5 there. And that's going to be times the determinant of. And I take that row and column and take it out. It's going to be the 2, 3, and the -1, 4. Okay, so that's going to be 2, 3, and then -4 and 1. And then for the last one, it's going to be this 2 here, so +2, it's positive. And then for that determinant, I'm going to take that row and that column out, and it's going to be 2, 1, 3, -3. So there's the third one. Now, like I said, I'm going to do the calculation for this one to show you, just to get a little more exposure to it. But for the other ones, I'm just going to give you the answers for those. So this is really going to be 6. Let me do a better 6 there. 6 times 1 times 1 is 1, minus -4 times -3 is +12. So that's going to be 1 minus 12. And the next one's going to actually be a +5 because of negated negative. And then that's going to end up being 2 minus, and that's going to end up being a -12. Okay, and that's the second one. Now for the third one, it's going to be +2 times, and that's going to be -6 minus, and then that's going to be a +3. So there it is. Now I can clean this all up here. And this is really going to result in 6 times -11 plus 5 times, and this is going to end up being 14, and plus 2 times, and that'll end up being 9. Hoping that almost caught me. It's not actually a 9 on the end here. It's actually a -9. Okay, so I'll fix that. So excuse me. So then from here, I can add all these up. And by adding them all up, I would get -14. So it equals -14. I want to put that up top there because I'm going to show you the rest of these now. So then for my dx is going to equal, now remember what I'm doing here, I'm taking that number column, and that's going to be my first row because I'm in the x column here. And then my y and z column are going to stay the same. So that's just going to come from where d is at. So it's going to be those two columns that stay exactly the same. So my first one is going to be 3, 5, -1, because that's my number column. That's what we see here. Okay. No, not there, but here, excuse me. So we see that this column here is my constant column, and now my b and c are going to stay the same here. And that's going to be these two. Okay, so that's going to be the -5, 1, -3, and then 2, -4, and 1. And that's the last column there. So there's my dx. And then dy is going to equal, and if you notice this, now this 3, 5, -1, that's my k1, k2, k3, is now going to be in the middle. So my first column stays the same, so it's going to be the 6, 2, 3. And then my middle column is now going to become that 3, 5, -1. And then my last column is going to stay the same, so that's going to come from here. That's the 2, -4, and 1. So there's dy. Then I have one more to do as my dz. So then for my dz is going to equal, and my a and b columns are the same here. They just use a and b. That's usually our x and y. But anyways, nonetheless. So that's going to be my 6, 2, 3. And again, it's coming from here, from this piece here. Okay, and then my b is going to be the same too, so that column is going to be the same. So that's going to be -5, 1, -3. Now, one of the big problems here that you might want to be careful with is make sure when you're rewriting these that you don't mix anything up or miss a sign. It's going to be so easy to do here because I'm moving around a lot, it seems like. And then for my last column, that's going to be my number column. That's why I call it dz. And that's going to be that 3, 5, -1. Oops. 3, 5, -1. So there's my third one. That'll be my dz. Now I'm just going to give you the values for those. So we get -56. And then for dy, we're going to get -70. And then for dz, we're going to get -28. Now these can also be done on your calculator using the function det, which means determinant. So I can do the determinant and then just plug in the matrix there of which each of these here, and that would actually give me the answer for that. And it works on both the 89 and the TI Inspire CAS. So my x then, remember, it's going to be my dx over d. So my dx is -56, and over d is -14. So then x equals 4. I'll write that there. There's my x. And I do the same thing for my y, so that's going to be my y equals my dy, which is -70 here, divided by, and my d is -14. And then my y is going to equal 5. And then for my z here, my z is going to equal my dz, which is -28, over -14, which equals 2, because I ran out of room here. So there's my z. My z equals 2. So there's the answer for this one here, and essentially just go through the process using this algorithm here to find the solution to the system of equations. I don't know what would be easier here. I guess if I used my calculator to find the determinants, that's what we would call these here. So using det function, if I use that, this might be an easier process than going through the reduced row echelon form. So anyways, there it is. So we could also find the solution for this using the reduced row echelon form, and then XYZ, or the elimination method that we learned in the section even before that section. So there it is. 3 different ways to find the same information.